How does a wagon move as you let it roll freely on a ramp? The answer to that question is that the wagon accelerates downhill. Now, it's tempting to think that the wagon moves downhill, but that's not necessarily true. If I start the wagon heading uphill, watch what happens to it. It initially is moving uphill, it comes to a stop, and then it rolls downhill. So it's not necessarily moving downhill while it's rolling freely. What you can say, though, is that it's always accelerating downhill. So if I let go of it from rest, it starts from rest and develops more and more downhill speed, and that's indicative of downhill acceleration. And if I start it from moving uphill, it initially is heading uphill, that's its velocity, but its acceleration is still downhill. It's losing its uphill speed. It's going slower and slower. It momentarily comes to a stop, but it's still accelerating downhill, and then it continues its travels downhill, going faster and faster. So, long and short of it is, a wagon that's rolling freely on a ramp is accelerating downhill, and we can't say anything specific about its velocity without more information. Well, that brings us to the issue of where does this downhill acceleration come from? Why does a wagon on a ramp accelerate in that particular direction? And the answer to that is the net force on the wagon, once I let go of it, is downhill. And it's accelerating in the direction of the net force on it, like anything else. Well, that just passes the buck. Why is there a downhill force on the wagon? That turns out to come from the interaction of two separate forces. One is the wagon's weight, which is straight down, as always, toward the center of the earth. The second force acting on the wagon is the support force from the ramp. Now, if you recall, support forces act perpendicular to the surfaces that exert them. For example, when the ramp wasn't a ramp at all, but rather a sidewalk, it's a horizontal surface, and the support force it exerts is therefore vertical. I can show you the direction again with my little stick. So this is a horizontal surface, and it exerts vertical support forces on the things that sit on it, that touch it, that try to penetrate into its surface. But when we tip this sidewalk into a ramp, it's not horizontal anymore. And the support forces it exert aren't vertical anymore. They're up and to your right. So the support force on the wagon is now up and to the right. It's in this direction. And a force that's up and to the right can't cancel a force that's straight down, the weight of the wagon. Those two forces add up to something. They don't add up to zero. They can't cancel. Instead, the downward weight and the up and to the right support force add together to become a very small net force that's downhill, that's exactly along the surface, parallel to that ramp surface. And it's that net force in the downhill direction that causes the wagon to accelerate downhill when I let go of it. Now, I call the net force on the wagon that points downhill the ramp force. And the ramp force isn't a new kind of force. Rather, it's the sum of two separate forces that don't quite cancel. The wagon's downward weight and the not quite upward force, support force exerted by the ramp on the wagon. Those two forces, when you sum them together, produce this downhill net force, this ramp force, that causes the wagon to accelerate. The amount of downhill ramp force depends on the steepness of the ramp. To show you that, I'll start with no ramp at all. Go back to a horizontal surface, and now the downhill ramp force is zero. That's because the cancellation is perfect between the wagon's downward weight and the vertically upward support force from the horizontal ramp. But as I start to tilt the ramp just a little bit, now there's a downhill ramp force. And that ramp force is equal to the wagon's weight times a number that's smaller than 1. That number turns out to be the height of the ramp, which in this case is about 10 centimeters or 4 inches, divided by the length of the ramp, which is 4 feet or a bit over a meter. So it's about a 10-to-1 ratio, and that means that the downhill ramp force on this wagon is about 1/10 of the wagon's weight and aimed along the ramp. If I tip the ramp still further, we've got more downhill ramp force. That's because the height's larger, the length's the same, the ratio now is more like 5-to-1. I can keep going. I don't have the reflexes to keep going without some help. So now, bigger ramp force. And the extreme case is when I take the ramp up to full vertical. In this case, the ramp force, which is straight down, is the full weight of the wagon. So the ramp force evolves perfectly from 0, the ramp is horizontal, and I've got no spacers here. It evolves continuously to larger and larger ramp forces all the way to the full weight of the wagon. The steeper the slope, the bigger the downhill ramp force. This slope on the grass is a whole lot steeper than a handicap access ramp. So the downhill force will be big, and so will my acceleration. Don't try this at home. Professional driver here. And off we go. Big downhill force, fast acceleration. It's pretty clear now that if you let a wagon roll freely on a ramp, it accelerates downhill. But what if you intervene and you exert an uphill force that's equal in amount to the downhill ramp force? How does the wagon move? If you exert an uphill force on the wagon that exactly cancels the downhill ramp force, the wagon is inertial, and it moves as an inertial object. It coasts. If it happens to be motionless, as it is now, it remains motionless. But if it's moving, it keeps moving at constant velocity. So let me get it moving. Here we go. Now, it's inertial. I'm balancing ramp force. I ran out of ramp, but that's the idea. It can coast uphill. There it is. Or it can coast downhill. Let me get started. There we go. Those are all possible situations where you've perfectly canceled the downhill ramp force by exerting your own uphill force of an equal amount. We've seen that when you pull uphill just enough to cancel the wagon's downhill ramp force, that the wagon becomes inertial and it can be motionless or coasting. But what if you pull a little too hard or a little too soft? In that case, the wagon does accelerate. For example, if I pull a little too weakly in the uphill direction, the wagon accelerates gently downhill. And if I pull a little too hard in the uphill direction, the wagon accelerates gently uphill. That allows us to control the wagon's motion. For example, how do I get the wagon to go from the bottom of the hill to the top of the hill? What's the whole process? The whole process has 3 parts. Let's start with the wagon at the bottom of the hill and motionless. And my goal is to get it to the top of the hill and motionless. Here are the 3 steps I've got to do. First, I've got to make the wagon accelerate uphill by pulling it uphill a little extra hard. So I'm going to do that just a little and get it moving. Here we go. Little extra strong pull, little upward hill acceleration. I'm good to go now. Now the wagon is coasting. I'm no longer pulling extra hard. I'm simply balancing the downhill force. And now I'm getting to the top of the hill. Now I've got to bring the wagon to a stop. How do I do that? Pull a little less hard and under support the wagon so that it accelerates downhill opposite its uphill velocity and it slows to a stop. So just to make sure you can follow that, let me do it again. I'm going to go to the bottom of the hill. A miracle occurs when we're at the bottom of the hill again. And now I pull a little extra hard to get it started. Now I just pull enough to keep it coasting. And now I pull a little extra weak at the top to let it slow to a stop. And we're done. This actually works in reverse to go downhill. Suppose I've got the wagon at the top of the hill, which I do, and I want to get it to the bottom of the hill, from stopped to moving to stopped. Well, I under support the wagon at first so it accelerates in the downhill direction, gets moving. There, I've done it. Now I let it coast. I simply support the downhill ramp force. And now I want to stop it. So I pull uphill a little extra hard and slow it to a stop. You use processes like these to move objects up and down ramps all the time without even thinking about it. Most of the time, you simply support the object against its downhill ramp force so that it coasts. But you use subtle adjustments in your uphill force to cause the object to start or stop. Well, the trip uphill, simple. The trip downhill, simple. They sure look similar in terms of physics up to this point, but they feel very different. You know from experience that dragging something uphill is a lot more fatiguing in many ways than lowering it downhill. In the next segment, we'll talk about what distinguishes the trip up from the trip down.